Junction field effect transistors JFET contain how many diodes? A4, B3, C2, D1. The correct answer is 2. When an input delta of 2V produces a transconductance of 1.5 ms, what is the drain current delta? A 666 mA, B 3 mA, C 0.75 mA, D 0.5 mA. The correct answer is 3 mA. When not in use, MOSFET pins are kept at the same potential through the use of A. shipping foil, B. non-conductive foam, C. conductive foam, D. a wrist strap. The correct answer is conductive foam. D-MOSFETs are sometimes used in series to construct a cascade high-frequency amplifier to overcome the loss of A. low output impedance, B. capacitive reactance, C. high input impedance, D. inductive reactance. The correct answer is high input impedance. A U-shaped opposite polarity material built near a JFET-channel center is called the A. gate, B. block, C. drain, D. heat sink. The correct answer is gate. When testing an N-channel D-MOSFET, resistance G to D, resistance G to S, resistance D to SS, and 500 depending on the polarity of the ohmmeter, and resistance D to S 500. What is wrong? A. short D to S, B. open G to D, C. open D to SS, D. nothing. The correct answer is nothing. In the constant current region, how will the IDS change in an N-channel JFET? A. as VGS decreases, ID decreases, B. as VGS increases, ID increases, C. as VGS decreases, ID remains constant, D. as VGS increases, ID remains constant. The correct answer is as VGS decreases, ID decreases. A MOSFET has how many terminals? A. 2 or 3, B. 3, C. 4, D. 3 or 4. The correct answer is 3 or 4. IDSS can be defined as A. the minimum possible drain current, B. the maximum possible current with VGS held at 4V, C. the maximum possible current with VGS held at 0V, D. the maximum drain current with the source shorted. The correct answer is the maximum possible current with VGS held at 0V. What is the input impedance of a common gate configured JFET? A. very low, B. low, C. high, D. very high. The correct answer is very low. JFET terminal legs are connections to the drain, the gate, and the A. channel, B. source, C. substrate, D. cathode. The correct answer is source. A very simple bias for a D-MOSFET is called A. self-biasing, B. gate biasing, C. zero biasing, D. voltage divider biasing. The correct answer is zero biasing. With the E-MOSFET, when gate input voltage is 0, drain current is A. at saturation, B. 0, C. IDSS, D. widening the channel. The correct answer is 0. With a 30-volt VDD and an 8 kΩ drain resistor, what is the E-MOSFET Q point voltage with ID 3 mA? A. 6V, B. 10V, C. 24V, D. 30V. The correct answer is 6V. When an input signal reduces the channel size, the process is called A. enhancement, B. substrate connecting, C. gate charge, D. depletion. The correct answer is depletion. Which JFET configuration would connect a high resistance signal source to a low resistance load? A. source follower, B. common source, C. common drain, D. common gate. The correct answer is Source follower. How will electrons flow through a p-channel JFET? A. From source to drain. B. From source to gate. C. From drain to gate. D. From drain to source. The correct answer is from drain to source. When VGS 0 V a JFET is A. Saturated. B. An analog device. C. An open switch. D. Cut off. The correct answer is saturated. When applied input voltage varies the resistance of a channel, the result is called A. Saturization. B. Polarization. C. Cutoff. D. Field effect. The correct answer is field effect. When is a vertical channel E-MOSFET used? A. For high frequencies. B. For high voltages. C. For high currents. D. For high resistances. The correct answer is for high currents. When the JFET is no longer able to control the current, this point is called the A. breakdown region. B. depletion region. C. saturation point. D. pinch-off region. The correct answer is breakdown region. With a JFET, a ratio of output current change against an input voltage change is called A. transconductance. B. Siemens. C. resistivity. D. gain. The correct answer is transconductance. Which type of JFET bias requires a negative supply voltage? A. feedback. B. source. C. gate. D. voltage divider. The correct answer is gate. How will a D-MOSFET input impedance change with signal frequency? A. As frequency increases, input impedance increases. B. As frequency increases, input impedance is constant. C. As frequency decreases, input impedance increases. D. As frequency decreases, input impedance is constant. The correct answer is as frequency decreases, input impedance increases. The type of bias most often used with E-MOSFET circuits is A. constant current. B. drain feedback. C. voltage divider. D. zero biasing. The correct answer is drain feedback. The transconductance curve of a JFET is a graph of A. IS versus VDS. B. IC versus VCE. C. ID versus VGS. D. ID RDS. The correct answer is ID versus VGS. The common source JFET amplifier has A. very high input impedance and a relatively low voltage gain. B. a high input impedance and a very high voltage gain. C. a high input impedance and a voltage gain less than 1. D. no voltage gain. The correct answer is a very high input impedance and a relatively low voltage gain. Using voltage divider biasing, what is the voltage at the gate VGS? A. 5.2 V. B. 4.2 V. C. 3.2 V. D. 2.2 V. The correct answer is 5.2 V. The overall input capacitance of a dual-gate D-MOSFET is lower because the devices are usually connected A. in parallel. B. with separate insulation. C. with separate inputs. D. in series. The correct answer is in series. What is the transconductance of an FET when ID 1 mA and VGS 1 V? A. 1 Ks. B. 1 ms. C. 1 K. D. 1 m. The correct answer is 1 ms. Which component is considered to be an off device? A. transistor. B. JFET. C. D-MOSFET. D. E-MOSFET. The correct answer is E-MOSFET. In an N-channel JFET, what will happen at the pinch-off voltage? The value of VDS at which further increases in VDS will cause no further increase in ID. B. The value of VGS at which further decreases in VGS will cause no further increases in ID. C. The value of VDG at which further decreases in VDG will cause no further increases in ID. D. The value of VDS at which further increases in VGS will cause no further increases in ID. The correct answer is the value of VDS at which further increases in VDS will cause no further increase in ID.